So this lecture begins with the discussion of the triangle sum theorem, and the triangle sum theorem is stated up above, where it states the sum of the interior angles of a triangle is equal to 180 degrees. This is a fact that we've been using with triangles for some time, but now we would like to prove it. So let's begin by numbering our angles of the triangle. I'll number them 1, 2, and 3. And we want to prove that angle 1 plus angle 2 plus angle 3 is equal to 180 degrees. So to do this proof, we're going to call on something called the parallel postulate. The parallel postulate states that I can draw a parallel line through any point not on the line. So this vertex of the triangle, I'm drawing a line through, and I'm drawing it so that this line is parallel to the side opposite of that point. Similarly, if I wanted to, I could have drawn a line that goes through this point so that it is parallel to this side. Or we could have done it with the third point and its opposite side. So let's just stay with the line going through the top vertex parallel to the base down below. Once you've drawn the line so that it is parallel, that means these other sides of the triangle, we can think of them as transversals. And if this is the transversal, and these are our two parallel lines, then the alternate interior angles are congruent, and I can put angle 2 up here saying that this angle up above is the same measure as angle 2 from the interior of the triangle. Similarly, we can do this with this angle number 3. And we can say that angle number 3 is alternate interior to this angle up above. And if you like, we can draw this side extended through here and label it as a transversal. So we see our alternate interior angles here once again. So all three of these angles together, we can say add up. Angle 1 plus angle 2 plus angle 3 add up and are equal to 180 degrees using the angle addition postulate. Because angle 1, 2, and 3 are now being used to form a straight angle. So if 1, 2, and 3 form a straight angle and are equal to 180 degrees, then 1, 2, and 3 inside the triangle also add up to 180 degrees, and this is why there is 180 degrees in every triangle. And you can do this from any of the points and any of the sides. You can say, let these two sides be parallel, and then you can label your angles inside the triangle, find your angles that are alternate interior, and show that those three angles form a straight angle and add up to 180 degrees. Therefore, the angles inside the triangle do as well. Now we can use the triangle sum theorem to solve algebraic problems with triangles. Here we see that we have angle J plus angle K plus angle L, and we know that they must add up to 180 degrees. We can replace J, K, and L with their algebra that represents each angle. So 3x plus 2x plus 40 plus 60 minus x equals 180. Now you can combine like terms. So we have 3x plus 2x is 5x, minus 1x is 4x. We have 40 plus 60 is 100. Subtract the 100 from both sides, and we have 4x is equal to 80. Divide both sides by 4, and we find that x is 20. Once we have that x is 20, we can plug that 20 into x for each angle, and we'll find that J is 60 degrees. K is 2 times 20, which is 40, plus another 40 gives us 80 degrees. And L is 60 minus 20, which is 40 degrees. And we see that 60 plus 80 plus 40 equals 180, just to verify that our numbers add up to what they should. The next theorem we would like to discuss is the exterior angle theorem. And what the exterior angle theorem states is that an exterior angle of a triangle is equal to the sum of the two non-adjacent angles in a triangle. So an exterior angle is created by extending one side of the triangle past its vertex. And here we see that angle CBA is an exterior angle. So now I'm going to label these angles 1, 2, and 3 inside the triangle and angle 4 outside. We know that angle 1 plus angle 2 plus angle 3 is equal to 180 degrees. We just proved this in the Triangle Angle Sum Theorem. We also know that angle 3 plus angle 4 is 180 degrees because they are a linear pair. Since they are both equal to 180 degrees, that means I can take this angle 3 plus angle 4 and put it in place of the 180 degrees in the equation above. This gives us a new equation, angle 1 plus angle 2 plus angle 3, that's the left side of this equation, is equal to, I'm going to replace the 180 on the right side with angle 3 plus angle 4, because both of these sums are equal to 180. Now, notice we have an angle 3 on both sides, so let's subtract it from both sides. It cancels itself out, and what we're left with is that angle 1 plus angle 2 is equal to angle 4. Angle 1 plus angle 2 is equal to angle 4, which is what the exterior angle theorem says, that an exterior angle of the triangle is equal to the sum of the two non-adjacent angles. We see that angle 3 is adjacent to 4, but angle 1 and angle 2 are not adjacent to 4. So those two added up will be equal to 4 every time. We can do this again. I like to rotate where the exterior angle is. You can see that we've extended side XY to create an exterior angle on a different part of the triangle. I'm going to number the angles inside the triangle, 1, 2, and 3, and the angle outside is 4. As we did with our previous example, we can show that the sum of the interior angles of the triangle add up to 180 degrees. We can show that angle 1 and angle 4 are a linear pair and therefore supplementary. So I can write angle 1 plus angle 4 is equal to 180. And now we're going to take this 180 in the top equation and replace it with something else equal to 180, which is angle 1 plus angle 4. We see that I kept the left side of the equation exactly the same, but now we're replacing the right side of the equation. And this time we see that angle 1 is the angle that shows up on both sides. So we'll subtract it from both sides, and we see that it cancels itself out, and we're left with angle 2 plus angle 3 is equal to angle 4. Well, angle 4 is our exterior angle, and angle 2 and angle 3 are the two angles not adjacent to 4. We see that in this drawing, angle 1 was adjacent to 4. Angle 2 and 3 are not adjacent to 4. So the exterior angle is equal to the sum of the two non-adjacent angles of the triangle. So now we can solve a problem like this, because we know the exterior angle theorem says that we can take this exterior angle, 7x plus 15, and set it equal to the sum of the two non-adjacent angles in the interior of the triangle. So we have 3x plus 45. That's the sum of the two non-adjacent angles. And if we combine like terms, we have 4x plus 45. We can now subtract 4x from both sides. We can subtract 15 from both sides. And we find that x is equal to 10. Now, angle WXZ. WXZ is the exterior angle. We'll plug in 10 for x. That'll give us 85 degrees. YXZ is the angle adjacent to WXZ. So since it's adjacent and a linear pair, we can subtract 85 from 180, and that gives us 95 degrees. Angle Y, we're going to replace x with 10, and we get 30 degrees. And angle Z, when we replace x with 10, we get 55 degrees. And these are the three angles of the triangle, and you can check and see that their sum is 180. And angle Y and angle Z are the two angles not adjacent to the exterior angle. And we can see that 30 plus 55 is equal to 85. So all of the properties we discussed are working with our numeric results. So this is the end of this lecture. Go back, listen to it again, take notes, and then move on to the practice.